Nomenclature is the term for a system of names or terms, or for the system of principles, procedures, and terms related to assigning a specific word or phrase to a particular object or property. The goal of chemical nomenclature is a set of rules that generate systematic names for chemical compounds. Ideally, every inorganic compound should have a name from which an unambiguous formula...
Excuse me.
Yes.
Do you think you could explain that a bit simpler? I mean, they are just humans you're talking to.
Fact. The intelligence dampening sphere doesn't understand a word of what you just said.
I do so.
In layman's terms, nomenclature is names for things, in this case, a system of names for chemical compounds. If you'd like to break it down, we'll start with the names and formulas of ionic compounds. Since you're so knowledgeable, why don't you do it?
Alright. Ionic compounds are metal ions and nonmetal ions. Metals form positive ions and nonmetals form negative ions. Positive ions, which have fewer electrons than protons for the record, hence it's positive, are called cations. Cations of a metal have the same name. This is simply referred to as a sodium ion. This is a zinc ion. Now, if a metal can form more than one cation, its positive charge is indicated by a Roman numeral after its name. So this is an iron 2 ion, and this is an iron 3 ion. This is a copper 1 ion, and this is a copper 2 ion.
Maybe you actually are good for something. Also, for the record, charges aren't always indicated. But using a Roman numeral to indicate such is never wrong, just unnecessary.
Right. Also, most metals that can form more than one cation are transition metals, the ones in the middle block of the periodic table. And finally, cations formed from nonmetals have names that end in IUM, like the polyatomic NH4 plus ammonium.
Oh, is it my turn now? Negative ions are known as anions. And you know an ion's negative when you have more electrons than protons. Monoatomic anions are named by replacing the ending of the name with IDE. This is a hydride ion. This is an oxide ion. Polyatomic anions containing oxygen have names ending in ATE or ITE. Anyway, these are called oxyanions. 8 is used for the most common oxyanion of an element. Ite is used for an oxyanion that has the same charge but one atom fewer. You can remember that because it rhymes with dynamite. The dynamite that blew that extra oxygen straight to the moon. Anyway. SO4 2- is sulfate. SO3 2- is sulfite. NO3- is nitrate. NO2- is nitrite. Prefixes are used when the oxyanions in an element have up to 4 members in a group, as is the case with halogens. Per indicates one more O atom than the oxyanion ending in 8. Hypo indicates one oxygen atom fewer than the oxyanion ending in ite. ClO4 is perchlorate. ClO2- is chlorite. ClO3 is chlorate. ClO- is hypochlorite. Anions derived by adding H+ to an oxyanion are named by adding hydrogen or dihydrogen as a prefix. CO3 2- is carbonate. HCO3- is hydrogen carbonate. PO4 3- is phosphate. H2PO4- is dihydrogen phosphate. And that's all I have to say about that.
Ionic compounds. Names of ionic compounds. Naming ionic compounds.
Names of ionic compounds consist of that cation name followed by the anion name.
Calcium chloride. Yeah, calcium chloride. Aluminum nitrate. Aluminum. Copper 2 chloride. Perchlorate. Perchlorate. Fact. Acids are a class of hydrogen-containing compounds and are named in a special way.
And as I'm sure you know, an acid is a substance whose molecules yield hydrogen ions, H+, when dissolved in water.
That is correct. Also fact. At this point, acids will be written with hydrogen as the first element, as in HCl and H2SO4. An acid is an anion connected to enough H+ ions to neutralize or balance the anion charge. SO4 2- requires 2 H+ ions to form H2SO4. Fact. Acids containing anions ending in IDE are named by changing IDE to IC and adding the prefix hydro to the anion name, then adding the word acid. Cl- is chloride. HCl is hydrochloric acid. S2- is sulfide. H2S is hydrosulfuric acid. Fact: acids containing anions whose names end in ATE or ITE are named by changing ATE to IC and ITE to OUS, then adding the word acid. Prefixes in the anion name are retained. Here are the oxyacids of chlorine: perchlorate, chlorate, chlorite, hypochlorite. Perchloric acid, chloric acid, chlorous acid, hypochlorite acid. Fact: this concludes the section on acids.
Binary molecular compounds contain two elements, but follow similar rules as ionic compounds. The name of the element farther left in the periodic table is usually written first. In compounds that contain oxygen, however, oxygen is always written last unless paired with fluorine. If both elements are in the same group, the one with the highest atomic number is named first. The name of the second element is given an "ide" ending. Greek prefixes are used to indicate the number of atoms of each element. Mono is never used with the first element. Cl2O, dichlorine monoxide, N2O4, dinitrogen tetroxide, NF3, nitrogen trifluoride, P4S10, tetraphosphorus decalcified. Molecular substances can be predicted in the same way as ionic compounds. Some molecular compounds use prefixes that explicitly state their composition.
However, molecular compounds that contain hydrogen and one other element are an exception, and can be treated as neutral substances containing H+ ions and anions.
You know that hydrogen chloride is HCl, since H+ balances with Cl-, and hydrogen sulfide is H2S because S2- balances with the two hydrogens.
Right. Now if you all are quite finished, please get back to testing.